How's it going? I'm Scott Moss, Senior Software Engineer at Netflix, and this is AI Engineering Fundamentals. I believe AI engineering is a skill of the future. In fact, it's here today. So many companies are hiring for AI engineers, and in this course, you're gonna learn what it takes. In this course, we're gonna cover everything from building an agent from scratch, using evals to measure and improve them with techniques like RAG, web search, tool calling, prompt engineering, and so much more. By the end of the course, you have built an agent that is dependable and reliable and ready for use. Become an in-demand engineer by learning how to build and improve agents so that they're actually dependable and useful. An AI engineer is like a system builder, because when I think of some AI-enabled experience, it's not really an app, it's like an entire system. So like taking things like foundational models like, Claude or GPT, whatever, and then turning them into like dependable, the key word is dependable product features, because it's so easy to make something that demos very well, right? Like something that's like, oh man, I just like vibe coded this thing in 5 minutes and it's so good. And I'm like, okay, cool. Let me throw 3 ands into your prompt and then let me see what happens, right? And then it's bad, right? Because it's not really dependable. And that's the science, that's the art, is like, how do you take something that has potential, but it's not really intelligent, it's really just a predictor, and how do we make that dependable enough to ship it to people to solve real problems? Because if it's not dependable, it's not going to be useful. Just like if you were to hire a person that wasn't dependable, that person probably wouldn't keep their job too long. So it's the same thing. So some of the things that we're going to cover that I think fall into AI engineering is context engineering, which is some term made up in Silicon Valley. It's just like basically, how do I send the right tokens to the model at the right time? Because tokens are currency. I mean, if you think about it, tokens correlate directly to energy cost. At some point, that's where we're all going, is like tokens per wattage at some point. So tokens really matter. Tool design. So like, how do we give agents the right abilities? Like, how do we make sure that they can do the right things and don't do the wrong things? Evaluation. So how do we measure our agents and so we can determine how dependable they are, and then like, how do we improve that? And then production reliability. So things like self-healing, user experience. How does a user know when something is broken? Handling errors, latency issues, different things like that. It's just a different it's like a completely different way of thinking of building applications. And it is on the application layer. And then we just need a function where we can extract this elements that we send up on the user message from the data parts type, so we can then inject it into our stream agent. So we'll make a function for that. This will just be called extract canvas state. It's going to take in the messages, which are type UI messages. It's an array of that. It's going to say any. Oops, not that type of function. Actually, I'll just do a const. There we go. And then the way the messages array works, the last message in the array on a new message is always the user message. So we can make that assumption and get the last message. So we can say messages at -1. So this will get the last message in the array. And again, the last message in the array when a new message comes in to the agent is always the user message. So we can make that assumption. So let's get the last message. Because it is a user message, and we've just changed the UI to send up a part every single time. We'll say, cool, last.parts.find. So let's find any part whose part.type is going to be that data canvas state. Cool. So if we have that, then we'll just return those parts elements. Or data.elements, because parts have a data field on them. Otherwise, it's just an empty array. So this is us extracting it. And then the last thing we need to do is down here is we get our canvas state. And this is going to be extract the canvas state All we need to do is pass in this.messages. We get that for free. Got our canvas state. And from there, when we call stream agent, we have the canvas state property that we just created. We could just pass it there. We could test this. Let's see. Let's test this right quick. Let's see if we can do, if nothing broke, let's just see. Oh, there we go. So if I think I have this running, all right, or what is this? That's the docs, okay. So let's say npm run dev. Cool, nothing broke. I like when nothing breaks. We can go here. I'm gonna put something on the canvas. I'm gonna put a square. I'm gonna put an arrow. I'm gonna put a circle. And then I'm gonna ask it, tell me what you see on the canvas. I see 3 elements on the canvas, a rectangle, an arrow, and an ellipses. Perfect. It can see the canvas perfectly. It was not able to do that before. This is substantially going to upgrade the agent and its capabilities, the fact that it can see. But I want to see our scores go up. So let's apply this code. Let's get this skeleton code here. And if you go to context, make a new file called apply skeleton. And we can put that in there. And then from here, what we need to do is we need to go into our server side add elements thing here on our eval that I created for you guys. And we need to apply the skeleton here. So we can go to that. That's going to look like, where is that? That is, let me see, add elements. Oh yeah, here we go. Eval tools inside of agent core. So inside of here for the eval tools, we need to simulate what I'm calling like the runtime that we get from this skeleton, which is a true representation of what Excalidraw will export. It's basically just the real representation as close as I can get it, so we can associate that with our simulation and then add that to the information so the evals are just more true. So we're hoping by just making the evals more true, we get free gains. We're not actually like optimizing anything. We're just like, let's just align our evals with what reality is, because unfortunately we have this system that things run on the client and the agent runs on the server. So we don't get that for free. Obviously, if your agent is just all on the server, you get that for free, but we don't. So that's what the point of this is. So let's do that. Oops. Oh, come here. Cool. And let's import our apply skeleton all the way up here. Context, apply skeleton, apply skeleton. Cool. And let me just bring that over. There we go. All right. So we did that. Now, if we run the eval for this, I don't expect anything to go down. I'll say that. But again, we were not directly addressing something. This is just like, well, we were aligning the schemas. Let's actually align the state as well to make sure that that aligns. We aligned the schemas and we got reality check. So let's try our first attempt at approving by just doing like, maybe this is free. Maybe this is low-hanging fruit. We have to do this anyway. Like we literally should be aligning the evals in the world that they see with production. So that is not even like something that's eval driven. It's just like good design. So let's start with that. And hopefully that will improve some evals. So boom, look at that. Massive gain, huge gain. I didn't think it was gonna be that big, but plus 94, I mean, you get a raise if you did that. That's a bonus. Like, that's insane.